Hi guys, I'm Abhijit Tesraj and welcome to my Lab 3 video. The objective of this lab is to estimate the mass of a black hole which is revolved around by a star. We have the motion data of that nearby star which was provided to us in the stardata.csv file. The software used for this lab is VPython, VIDLE for VPython, PowerPoint and CamStudio. And the physics concept involved is the momentum principle, more commonly referred to as Newton's second law, that is delta V final equals delta V initial plus the total force divided by mass the whole into delta T. And the procedure is we first set the appropriate system properties and also a convenient delta T. Here the time step is a day. The code is modified to calculate and print the total force or F-net of the system. By rearranging the terms in Newton's universal law of gravitation, we can solve for the black hole's mass. Finally, we arrive at an estimate which turns out to be about 5.5663687 e positive 31 kilograms. Let's look at the code for this lab. You can see that I have set the appropriate system properties. Here the star's mass, the delta T, the appropriate delta T in seconds. You can see that I have modified the code to print out the black hole's mass as well as the total force. Let's run this and see what happens. You can see that it works and it prints out sensible estimate for the black hole's mass. Now let's look at the what does it mean question. How is F-net, F-net perpendicular and F-net parallel different from delta P by delta T, delta P by delta T perpendicular and delta P by delta T parallel respectively? The answer for that is delta P by delta T is caused by F-net. The F-net causes a change in the momentum. Delta P by delta T perpendicular is caused by the perpendicular component of F-net, and delta P by delta T parallel is caused by the parallel component of F-net. That is the what does it mean question. And now let's look at the what if question. They have asked us to imagine the black hole whose mass that we found is being replaced by another black hole which is at the same location. They want us to assume that the mass they want us to assume that the motion of the star revolving around the black hole is unchanged. They are asking us whether it is possible to find a value for the mass of the new black hole that is different from the mass you found for the original one. Well, the answer is that I cannot find a difference between the two black holes, and if their mass is different, there has to be some difference in the other variables. That's all. Thank you for watching my Lab 3 video and see you next time.